Let's walk through an example where we do a hypothesis test for matched pairs. Let's say a study was conducted to investigate the impact of hypnosis on reducing pain. Pain scores were recorded before and after treatment. Alpha equals 0.01 was used in the study. So let's give our data before and after. Person A's before pain score was 6.6, after it was 6.8. Person B's before score was 6.5, after it was 2.4. Person C's before score was 9.0, after it was 7.4. Person D's before score was 10.3, after it was 8.5. Person E's before score was 11.3, after it was 8.1. F's before score was 8.1, after it was 6.1. G's before score was 6.3, after it was 3.4. And H's before score was 11.6, after it was 2.0. In order to get a better idea of these numbers and what we're going to be working with here, let's hop over to Excel to help with some of the calculations. I've copied the data over to this Excel sheet, so I've got person A through H, their before pain score, and their after pain score. In order to do a hypothesis test on the matched pairs, we're really interested in the difference in score. When we do the difference, we're going to take the after minus the before. It's really important we subtract what kind of feels like backwards in order to get the correct difference. So on Excel, I can say equals, click the after minus the before, and when I hit enter, it's going to give me the difference score. By clicking that dot in the bottom right corner, I can copy that formula all the way down. And what we really need to know for this sample is the mean difference and the standard deviation of the difference. For the mean, I can hit equals, and the Excel command for the mean is average, open a parentheses, and select all the values and hit enter. And I get a mean difference of negative 3.125. For the standard deviation, I'll say equals stdev dot s, because we have a sample, open a parentheses, select the data, close the parentheses, and hit enter, and we get a standard deviation of, let's round it to 2.91. So using Excel, we found out that the average difference was equal to negative 3.125, and that the standard deviation of the differences is about 2.91. With those values in mind, let's run through our hypothesis test. The first step is to actually define the hypothesis. So we've got our null hypothesis that the average difference of the population is equal to 0. For the alternative hypothesis, we wanted to see if those pain scores were reduced. In other words, we're testing if that average difference is actually less than 0. We want those pain scores to be reduced. We want them to be negative. And so if we were to draw a picture of our situation here, here's our t-distribution with an average of 0. We want it to be reduced. We're doing a left tail test. Now that we know that, we can find our test statistic. For our test statistic, we first need to know the standard error. The standard error is equal to the standard deviation of the difference divided by the square root of the sample size. We found out the standard deviation of the difference was 2.91, And we'll divide by the square root of the sample size. We went all the way to H. H is the 8th letter of our alphabet, so there were 8 participants in this study. And so our standard error is 1.03. Then for T, our test statistic. The test statistic is the average difference divided by the standard error. The average difference that we found was negative 3.125, divided by the standard error that we just found, which is 1.03. And that gives us our t statistic of negative 3.03. Now that we have our test statistic, we know the fourth step is to find the p-value. Our p-value we can find on Excel. We are doing a left tail test, so that's going to be the t.dist command with the test statistic of negative 3.03. The degrees of freedom are 1 less than the sample size. There were 8 data values, so 1 less would be 7. And we have to say true with the left tail test. And when we do that, we end up with 0.0096. So that area on our picture, 0.0096, tells us that p-value. Based on that p-value, we can make a decision. So the p-value was equal to 0.0096. We said we wanted alpha to be 0.01. Notice that p-value is, in fact, smaller than the alpha. When we have a small p-value, we are allowed to reject the null hypothesis in favor of the alternative hypothesis. So then we can interpret this result by focusing our attention on that alternative hypothesis and putting it into context. We successfully rejected the null in favor of the alternative, which means we can say there is sufficient evidence at the alpha equals 0.01 level to conclude, and that alternate hypothesis says that the mean is lower, or the scores went down, that pain scores were reduced after the hypnosis treatment. So as you can see, doing a test for matched pairs feels a lot like doing a test for a single mean. In fact, it's exactly the same. The only thing we need to be aware of is we're working with the differences, the after minus the before. Find the average difference, find the standard deviation of the differences, and then run the hypothesis test for one mean.